In this video, I will be solving the second part of the third problem of UPSC Civil Services Mains 2025 Statistics Optional Paper 1. So the first part of this question says, let 6 minus 8, 3, 2, 7, 5, 4, 9 be a random sample from a population with probability density function f of x comma theta is 1 by 2 into exponent of minus mod x minus theta, and this x comma theta are ranging from minus infinity to infinity, and we need to find the maximum likelihood estimate of theta. So we can see this particular function is a Laplace density or double exponential density function. So first f of x comma theta, so that is 1 by 2 into exponential x minus theta. So if we consider the log likelihood for a sample, so log likelihood for a sample x1, x2 and so on xn, so that would be L of theta is summation I is equals to 1 to n log 1 by 2 minus I is equals to 1 to n mod xi minus theta. Now that means like this is just equivalent to finding for 1 minus n, like removing the constants. Basically it's we just need to the likelihood is just dependent on this particular function. So maximizing this L of theta is equivalent to minimizing this particular thing. So let S of theta be summation I is equals to 1 to n mod xi minus theta. So basically maximizing the likelihood L of theta implies minimizing this S of theta. And we also have a standard result. We already have a standard result. So the standard result is that so this S of theta is minimized by the median of the sample. So that means the MLE of this L of theta, or MLE of theta is sample median. So now here, like specifically if we see 1, 2, 3, 4, 5, 6, 7, 8, we are having 8 elements. So basically so for even n we have this middle order. The middle order statistics will be the median. So if we consider the sample is 6 minus 8, 3, 2, 7, 5, 4, 9. So 2, 7, 5, 4, 9. So if I order this sample, so that would be minus 8, 2, 3, 4, 5, 6, 7, 9. So this is ordered sample. So that means we can see n is equals to 8 here. So that means the middle values, so 4 and 5. So any convenient choice, like any value in between 4 to 5 will minimize our S of theta. So that means like any value in between 4 to 5 is our MLE. So MLE of theta is any value in this interval 4 to 5. We generally take, like commonly we take it as 4.5. So that's about the median of the first part. Now if we consider the second part of the question, so we were given x1, x2 and so on xn are the random sample from Bernoulli distribution where 0 less than theta less than 1, and we need to find the lower bound for the variance of unbiased estimator of theta based on this data. So we need to find the UMVUE of theta, and we also need to show that it attains Cramér-Rao Lower Bound. So there are like a lot of things in the question. So if I first consider x1, x2 and so on xn, suppose if these are following Bernoulli theta with 0 less than theta less than 1. So if I just consider t is equals to summation I is equals to 1 to n xi. So first we can see PMF, the probability mass function for any single observation is Px x theta is theta to the power of x into 1 minus theta whole to the power 1 minus x, where this x belongs to the set 0, 1. So if I consider the log likelihood for one observation, that is x log theta plus 1 minus x into log 1 minus theta. So if I consider the score for one observation, so that is nothing but u1 of theta, which is differentiation of this log likelihood. So that is nothing but x by theta minus 1 by x into 1 by x divided by 1 minus theta. So x minus x theta minus theta plus theta x by theta into 1 minus theta. So the score would be x minus theta by theta into 1 minus theta. So that means the Fisher information for this one observation, the Fisher information for one observation would be I1 of theta, which is expectation of the score square, which is 1 by theta into 1 minus theta. So that means so for n such observations, so for n observations, so we will be having n I1 theta, so that is n by theta into 1 minus theta. So that means so that means the variance so the variance of this theta hat is greater than or equal to 1 by in of theta. So basically here we got in of theta, which is n by theta into 1 minus theta. So variance of theta hat would be greater than or equal to 1 by n of theta. So that is nothing but theta into 1 minus theta by n. And we can see the regularity conditions required for this Cramér-Rao inequality are hold here for the values in between 0 to 1 of theta. Now if we consider the same statistic t, which is xi, so this follows binomial n comma theta, and if we see by factorization theorem, so t is sufficient for theta, and it's also from binomial. So binomial family is from exponential family, so that means we can also say t is complete. So that means so any unbiased function of t is the unique UMVUE. So that we can say it by Lehmann-Schaffer theorem. So by Lehmann-Schaffer theorem, so we can say that any unbiased function of t is unique UMVUE. So if we take the sample mean x bar is t by n. So this thing satisfies expectation of x bar is expectation of x1, which is theta. So therefore x bar is unbiased, and it's also a function of t. So that means x bar is UMVUE of theta. And if we find variance of x bar, so that is nothing but variance of t by n. That is nothing but 1 by n square of variance of t. That is nothing but 1 by n square into n theta into 1 minus theta, which is theta into 1 minus theta by n. So this is equal to the Cramér-Rao lower bound that we got earlier. So x bar attains Cramér-Rao lower bound. So the conclusion here is, so three things they have asked basically. Find the lower bound. So we found it as, so by Cramér-Rao lower bound we found, and we also found the UMVUE as theta hat UMVUE as x bar, which is 1 by n summation xi, and then like we have also checked this attaining this Cramér-Rao lower bound as of this unbiased estimator, and this attains CRLB, and hence it is UMVUE and efficient as well. So yeah, so that's about the second part of this third question. So that's it for this video. We'll meet in the next video.